Okay, so welcome to hybridization. 所以这里呢，我们会讲关于到 some shape of the organic molecules，还有我们的 sigma and pi bonds. It's gonna be a bit weird，因为很少只是想到 bonds 会用到 sigma 还有 pi 的。But let's have a look. So at the first stage，我们先 review 一下，我们这星期是有学过 orbitals。Okay, so we have learned about sp and d orbitals in the lone atom. But what about with hybrid? Okay, what is a hybrid? And before 我 introduce 这个东西，我们先看一下，当我们 electron 的时候，其实有一个东西叫做 excitation。OK， 那我们这一个呢，就讲着我们的 electron will start to be excited. What does that mean? 也就是讲着它会 up 我们的 bonding, as in up our orbitals. Okay, so what does that mean? 在我们 up 这个 orbital 的时候呢，我们可以讲它从 s 跳到去 p， 从 p 跳到去 d。OK， 或者是 D 跳去 S， 它一直要 upgrade 的，就是它的 electron go up rather than going down because it receives so much of the energy that it will bump up. It has the energy to pump up. Now, in this case， 在我们的 orbital 的时候，它们会开始 merge together after the excitation or even maybe without the excitation. 我们会开始就是 merge together, and that's what we call hybrid. Is when the orbitals will start to merge together. Okay, the electrons are rearranged to a hybrid orbitals, and this is what we call the process of hybridization. Now, before we move on, let's do a reminder. Remember that endothermic is always breaking bond, 因为我们需要就是 enter a lot of energy in order to break the bond. Okay, 就是 energy must be entered to the atom to break the bond. And we also need to make bond by doing exothermic. Okay. So how does it look like in electron excitation? Okay. 在我们的 electron excitation 呢，就是讲这 for example， 这个是我们的 carbon，so 1s2 2s2 2p2， 这个是我们的 normal state， 或者是我们所谓的 ground state。So in this case， 在这个 ground state 的时候，它会开始 excite，so we can see， 就是它一直吸收很多 energy。当它 up level 的时候，它就会去 p orbital，and this is what we call excited state. Okay, so basically giving a lot of energy, gaining a lot of energy, and it goes up. 所以看到吗？这里就是一个 electron 在这里。So in terms of hybridization， 我们会有很多不同的 state. So one of the state is sp3. Okay, and that's actually from the excited state of one of the s with one electron and three of the p's with one electron. Okay, 所以这个叫做sp3. 所以这一个就是因为有to kind of like minimize the repulsion， 还有它的 electron pair， 所以我们就可以得到 tetrahedral shape, which is 190.5 degree. What about with a combination of hybridization sp2? 所以 in this case， 我们有 boron， 而它 excite 了过后，它就可以得到这一个。Okay, so it's basically the same thing, but with different atoms or elements. So in this case， 我们就会讲 this is a hybridization of sp2， 因为我们一个 s 还有两个 p。And remember, with this makes a trigonal planar shape. Now the last one, which is sp orbital, which is basically, one example is beryllium， 然后我们就是这样一个 s 一个 p 而已。Okay, so it's basically the same thing, but with different bond angles of 180 bond in this case, which is a linear. Now, that probably it should be fine, but what about unhybridized orbitals? What does that mean? Let's have a look. So 我们这里有所有的 examples of carbon. So let's have a look. The first case we have orbital of sp3. Okay, with this sp3, we actually can just use all of them. Okay, so all of the orbitals have been used for hybridization. Let's have a look. After the excitation of this, 可是现在我要的是不同的 hybridization, which is sp2. What is happening here? 在我们这个 sp2 的 hybridization, 它就会拿一个 s 两个 p. It doesn't matter which p, but you'll notice we have one unhybridized p orbital. So basically, the hybridization that has not been used is called unhybridized orbital. 而它这个 p 它可以换成 s 或者是 d 或者是什么 regarding of the cases. Okay, so in this case we have 2p, so that means it's an unhybridized p orbital. The third case, which is only using sp, 1s and 1p, so it is 1s and 1p. So we have two unhybridized p orbital in this case. So that should sum up, and just remember one thing, hybridization even 就是有两个的时候 sp is always linear, sp2 is always 120 degree, 然后 sp3 is always our tetrahedral. And if you want to look further a bit, 这里有一个 YouTube clip, feel free to have a look at it. Now, I want you to answer this question in your own time, okay? So consider if there's water, does that hybridization occur here? If so, is it sp, sp2, or sp3? Another question, so feel free to answer this question. So what is the hybridization of sp? What is the hybridization of an atom A in the general molecule with the formula AB3? No lone pair. Question 2, the hybridization of the carbon of HCO3 negative ion and in a molecule of methane. Have a go at these questions. Now, 在这里的话，我们就开始讲关于到 orbital overlap. So, what does it mean? 所以就是讲这两个 orbitals 它们开始 overlap with each other, or maybe just think of it as touching each other. Okay, so we have different type of overlapping. We've got S to S, 所以看到吗？两个 S 是 stick 在一起的 ，S to P, 然后 S to PN, SP 这个 N 是代表任何的号码，可以是 one, two, three, okay, etc. etc. And then SPS and PZ 就是我们的那个 orbital level. Okay, so it's P to P. And now this type of overlapping we call it as sigma bond. Okay, this is all of them. That's what we call a sigma bond. Let's have a look at a special one. Now, we have another orbital that's what we call a pi orbital. Or not p, not pi orbital. It's called p orbital with pi bond. Okay, so in this case, 在 p orbital 的时候，我们可以有两个 bond， 一个是 sigma bond， 一个是 pi bond. Let's have a look at what I mean. 在这里呢，当我们是 n to n 的时候，在 p to p, okay, only exists in p to p 啊。When it's n to n, that's with sigma bond. Okay, so we can see that this is a sigma bond. But if it's side to by side, 也就是直直的，看到吗？ So that's resulting into a pi bonding. So that's the only condition. Okay. So let's have a look in this case. 在我的一定这里呢，我们的 hybridization is going to be sp2. Okay, and we have 3 of them. Okay, apparently. So let's have a look. How does it work? So 我们看这个 excited state. 我们在这里如果是跟着 sp2 的话 ，OK， 它只有一个 bonding. So where is the remaining of 2? Okay, let's have a look. One of them, of course, is going to be S to P2. Huh? Where's the S coming from? 它这里的 ethane 呢，其实是用了两个不同的 ethane. Okay, 也就是讲这 there are 2 of them. So that results into 一个 ethane, 这里有一个 sp2, 这里有一个 sp2. Another thing is, we also have between the black and white of the circles, that results into another sigma bond. Okay, but we can see from here there are only 2 of the bonds that we form. Okay, what about if we have pi bond in this case? So 我会用这一个 diagram 来去 introduce. So in this case 我们看到这里的情况 ，OK， 这里是SP and SP 它们 end to end 嘛，看到吗 ？OK， so we've got SP and SP joining together. That results into 1 sigma bond. And we said these 2 of the p orbitals that are not hybridized. Okay, 那这里的 remaining of the 2 will start to merge together. 那 2 of the p's 它们会弄成一个 half pi bond. So hence adding up top and bottom, 我们会 get into 1 bonding. So that's only 2 of the bondings here. 1 is sigma bond and 1 is our pi bond. But be aware, 如果我再加多一点 ethane 的话，它其实是 depending on your case. OK， 如果我的这里的一定是交进去这一个地方，还是说 join 去这个地方 ，the bonding number will be differ. So hence you have to draw the diagram out in the best case scenario. Okay, but it's not necessary, just some advice. So in case 如果你看不到这个 animation 的话，你可以在 your own time 看。But you can see that the purple is joined together, and then after that is we've got the red color. Okay, so you can see the S will start to join together, 然后 mix into the purple, and that results into 我们的SP2 的那个 hybridization. Then it becomes purple end to end joined together. That's 1 pi bond, and then red and red, which is our p orbital, that results into half pi bond and a half pi bond. So yeah, that's pretty much 他们做的那个方式. So we've got 2 bonding here. So that's the reason why we have double bond in our middle part. That's the reason. Okay. So feel free to look at animation in your own time too. So, what we'd like you to do in this question is answer this question: how many bonds does the ethane have? And are all of the bonds sigma bonds, pi bond, or combination? Think about the shape, think about the hybridization, electrons, and overlapping. Have a go at this question. Now, if 如果你是 get 不到的话，就是前面的那个问题 that's a little hint. If you want to skip this hint, feel free to skip it. But the hint is triple bonding. Yep. So, yes, there should be 3 bonds. 然后就像我们这一个一样，n square, n2 and HCN 它们同样的也是会弄成一个 triple bond 的。Okay, if you feel like it, feel free to kind of like draw it out. 然后你会发现到，我这里有一个 sigma bond， 然后这里有2个 pi bond. Okay, so feel free to draw it out and see how the combination works. So have a go at this question too. How many pi bonds and how many sigma bonds are there in total in one of the molecules C2CN bracket 4?